Thank you. The next presentation, let's just come. Guys from IMPA, who is presenting is Leandro Cruz, and just you.
Thanks by introducing. I am Leandro Cruz. I am a PhD student at WIVIS1 lab. It's a visual and computer graphics of the IMPA. I will present this work developed with together Djalma Lúcio and Luiz Velho. Unfortunately, the Professor Luiz Velho could not be here now. So I will talk about some research of interactive visualizations developed at WIVIS1. I will show some other things that are doing on WIVIS1, and I will talk about the RGBD research developed for us. Well, the WIVIS1 lab belongs to IMPA, the Institute of Pure and Applied Mathematics, that are on Rio de Janeiro. The groups are composed by 4 full researchers, 2 postdocs, 6 PhD students, and 1 master student, and 1 assistant manager, that is the Djalma, that is one of the authors of this work, and has a lot of other collaborators. About interactive visualizations research, some teams are developed in our lab. I will talk about some of them. About augmented reality, we can cite research using mobile and mixes of real and virtual objects. For instance, recently were present the master thesis, that is the bottom picture, that introduce virtual shadows on virtual objects that are captured by a mobile camera. And the top figure, we can see a panoramic image that has virtual objects with shadows and reflections. A drawback about the research that use augmented reality on panoramic images, it is necessary a model of the scenes. One possible future work is to automatically model the scenes using, for instance, the Kinect. Besides the augmented reality research using panoramas, other research is that were developed is this project called the Rio HK, that take the biggest picture on 2008. This image has 150 gigabytes. This is a super resolution image research. Another project that's called NPAN refers to create narrative histories related to panoramic images. These projects were developed together the ESD group, that is a group of design students of the WERJ. Another project developed in our lab was refers to interactive medias. This project began with multidisciplinary workshops on interactive medias and natural interfaces, present in 2008. This workshop was presented by Luiz Velho for students of computer science and design students. And The main goal of this workshop was to investigate new technologies for capturing, processing, exhibitions, and interactions with audio and visual data, and to develop some experiment as a proof of concept of the use of this table called iTable. In particular, this is one of our table. We have another multi-touch tables that were developed at WIVIS1. Another project refers to interactive horizontal stereoscopic displays. And this project proposes a new architecture for display stereoscopic images over horizontal surface. And this is the main motivations of this work is to project a stereo image in a horizontal table. This project has two basic configurations. A virtual table that consists of a single display surface, typically 3D monitors, and a virtual teleporter that consists of a pair of tables where we can capture objects put on the table and display in other table. And finally, we have been developed some research using RGBD camera, and in particular using Kinect. We have nowadays 10 Kinects, 12, 11 Kinects in our lab. This project began with the image processing course that was showed in last years, and in this Sibgrapi, we presented a tutorial called Connecting RGBD Images, Challenges and Applications, and tomorrow I will present 2 other works on the work in progress, besides this, of course. These teams, some projects were, we are developing some projects using RGBD cameras. We can cite project referent of image segmentations, interactions, feature tracking, and 3D reconstructions. Well, now I will talk about specifically the RGBD research. We use the Kinect, and Kinect is an example of RGBD device. It captures a colored image and measures the depth of each pixel using infrared patterns projected on the scene. This device is composed with an infrared projector and an infrared camera, besides a RGB camera. Besides this, there are microphones and motors to rotate the device head. The RGBD image is a colored image and a RGB images, and the depth data is the main motivations of this research is most of the image processing operates only on color channels of the image, and nonetheless there are other attributes that can be used in processing. You can cite depth and normal, luminance, among others. These attributes can carry information that further allow various procedures with an image. And with RGBD images, the RGBD images provided new possibilities to solve all the problems with better approaches. Some applications that we can cite using the Kinect is the Kinect Fusions and the Mirage table. And the Kinect Fusions is an interesting project about the 3D reconstructions that could be used in augmented reality, user interactions, and image segmentations. Besides these, the mirror table is another interesting system using Kinect. It's a complete immersive system that integrates stereo visualizations with interactions. Now, the proposed work is referring to RGBD camera effects. The main motivations is the realize object segmentations and object focus. One project developed with RGB videos is this paper's present on CEGRAPI. This paper is a robust method to extract objects in a video. However, it is necessary user interactions to select elements and fix some problems. With the help of the depth, we can help the method to extract the objects of the image with easier. About object focus, this work introduced a way to realize the focus effects during the scene rendering. This method was developed to model the scene. If we use a RGBD camera, we can obtain a model of the real scenes, and we can realize automatically operations like focus, for instance. Now, three effects that we can cite that we can realize with RGBD cameras is the filtering. We can implement visualizations using head tracking, and we can create stereo images. About filtering, this effect consists in filtering different image segments. Each segment refers to one or more objects in the scene, and the filtering process consists in three steps. The first is the selections of elements that will define the segments. The second is the image segmentations, and finally, we will filtering each segment. The segmentations could be done using the depth discontinuities and the depth boundaries, or we can use another methods like the grab cut plus D. This is a method developed at WIVIS1, or we can use some applications such as Kinect Fusion. Finally, the filtering consists in defining different shades to be applied in the image. This figure shows the pipeline. First, we have the RGB cameras. The second is the depth data. The third image is the element selections, and we segment we exemplify the two segments, and finally we show the filtered image. Segmentation process is the main step of this effect. If you use a RGBD image, we can obtain the segments more easier. Segmentation is a hard task on image processing, but if we use the depth data, we can obtain this segment more easier. If the depth data provided for the RGBD devices was perfect, the segmentation process is very easy. It just uses the depth discontinuities. The problems that we have today is the depth data is very noisy and has hole. Because of this, we need to apply some processing. After segmentations, we can process each segment with these respective filters. For instance, to simulate a camera focus effect, we can blur the entire image except the elements on focus. The stereo image creation is a process that is very interesting to 3D movies, for instance. Né? So 3D movies motivate the creation of the stereo image. This process is commonly done using two cameras. For capturing, some adjustments are done to produce some effects, such as focus, or improve the depth sensations. If you use the depth data, we can do this text easier too. Finally, the head tracking effect. We create an immersive visualization systems using the Kinect, tracking the head of the users, and with the head positions, we can move the scene to exhibit the parts which the user would see if he were facing a real scene. The effects simulate holography. The scene transformations induce the sensations of being really in front of a 3D object or 3D scenes. The main task to activate stereo visualizations is the head or eye tracking. We can solve this problem using the head provided by a skeleton, and this model is easier to obtain using the Kinect, for instance. Nowadays, some works have been used the Kinect to implement the head tracking. For instance, the mirror table. Finally, we present some tasks that are easier to do using Kinect, but Kinect has some problems. For instance, the Kinect data is low resolutions, has noise, it has rows. We believe that in near future will be available better RGBD devices. Thanks.
Oh, thanks for the presentations. Very nice. We have plenty of time for questions. Any question? The question again. Yeah. At the conclusion, you say that Kinect can be used to solve old problems in a new fashion or something like that. What problems are you talking about? And also, it's a nice, but I'm thinking what kind of applications can benefit from that, from this depth information, beside games? Okay.
We can cite 3D reconstructions. For instance, 3D scanning is a hard task to do, but the Kinect is a low cost scanning. There are some projects that do it. The Kinect Fusion do it. That we can use interactions in other applications besides games. Image segmentation is a problem that is easier if we use the depth data, among others.
Okay, what about the resolution? How many pixels?
640 for 408.
And do you have an idea why so limited? Or?
Yes, because the Kinect nowadays is using USB 2. So the device captures with a bigger resolution, but it cannot to transfer the data.
Okay, thank you. Okay. Any other question?
So in my group, we have been playing with the Kinect, trying to work on similar problems, including incremental 3D scanning using the sensor, and we have experienced a lot of problem with the sensor. It's very limiting in many ways. So what is your experience? I mean, things like the color camera is not registered with the depth camera, so the colors do not match. Synchronization is a problem. I don't know. What is your experience?
Yeah, we use the PCL library to scan in the lab, but the results is it's not good too. The noise difficult a lot this task. The 3D models is not so good as the Kinect Fusion results.
Any other question?
So you show some applications you do. Do you use directly the depth information, or you extract some features, 3D features from the sensor?
In this RGBD camera effects work, we use the depth data, the raw depth data, but it's possible to process the data, filter the data to obtain better model.
Okay, so but you're not using it.
No.
Okay, thank you.
Okay, more questions? No, so thank Leandro for the nice presentation.